For this, we have to install the library. Let me connect with my Raspberry Pi. So we have the Raspberry Pi screen here. So for this project, we need to do some basic setup so that we can start our coding. One of the basic setup that you need to do is to install the Python environment. So you can either use the virtual environment or normal Python ideally. So you can see I have already installed the Python ideally. You can also install it manually if it is not pre-installed in your Raspbian OS. So to do so, you can go to the preferences and add remove software and then search for the Python and install from here. Here you can see the Python in programming. We have to install the basic libraries for our coding. So to do so, we have to open the Linux terminal. You can either get the Linux terminal shortcut here in the Raspbian OS, or you can simply go to this and then on accessories you can get the terminal built here. So after opening this, you can now install the Python library. So there are different process by which you can install the Python library. You can either install the Python library by PIP, or you can just clone the library and then use the setup.py thing for the installation of the library. So here I am using the PIP to install the library. First I have typed the syntax sudo pip3 opencv install opencv. This will install the opencv. Uh, Sometime you might get the error. So if you get any version error, then check the version of the opencv that it is requiring and try to get the clone of that version in your Raspberry Pi. Then try to install the compiled library of OpenCV, and then we will need to install the iGame libraries on our Raspberry Pi. To do so, we have to type the sudo pip3 iGame, whatever the name of library. You have to just add at the end uh, uh, of this syntax, like I have typed the sudo pip3 install and then the name of library. So if you want to install the OpenCV, you have to just name it OpenCV. If you want to install the iGame, you can name it iGame. So after installing both the library, this library will help us in capturing our face, detecting our eyes, and then iGame will process the eye movement and get the direction of the eyeball movement. So these two things we have already set. Now next we will need a library so that we can control the GPIO pin of Raspberry Pi. GPIO stand for general purpose input output pin. So Raspberry Pi have lots of GPIO pins and interfaces pin. So for our robot, for the control of robot, like I give the eye gesture towards the upward, so robot will move to the upward direction or the forward direction. So to control the robot, we have to control the GPIO pin, and for that we need a library. So there are lots of options are available in the library to control the GPIO pin of Raspberry Pi. But here I am using the GPIO 0 library because it is efficient and easy to use, and there are some pre-built modules like the robot module by which you can simply call the function robot.forward and it will move the robot forward direction, a robot.backward, it will move the robot to the backward direction. So it is easy to use. That what I am using the GPIO 0 library. So after the installation of the GPIO 0 library, we have to start the coding. So before coding, let me tell you where such a project can be used. As we are getting the gesture of our eye, like we can detect whether we move our eyeball toward the right or left, upward, center, downward, top left, top right. So these are the eye movement and the gesture that can be recognized by our code, or you can say the eye game library. So we can use this in any way, like if you want to control a room, a fan in your room by the eye gesture, so you can control that. You can set the uh, eye gesture and GPIO 0 library to control the GPIO pin of the Raspberry Pi. Suppose that you have connected a relay board, the GPIO pin of the Raspberry Pi to the fan, and so when you move the and set a function that when the eye gesture is detected toward upward, fan will turn on, and when it detected the downward gesture, fan will automatically turn off. So you can also use it in controlling the home automation things like fan or light or something like that. Or you can also use this eye gesture in controlling the PC by there are lots of libraries you can get to control the PC like AutoPy GUI, or you can get Bin Auto, something like that, to control the Windows Auto, uh, to automate the Windows. That but this library only work on the Windows screen, not on Linux. So you can use this in many ways, and suppose that you want to control when the laptop screen. So when you move the eye toward the forward, toward the upward, so the page on the laptop screen will scroll towards the up. So you can use like that. But one of the basic use that I have made this project is for the robot, or you can say that for the wheelchair, like someone paralyzed person or one who is unable to walk and not able to even move their hand. He can now control his wheelchair using the motion of eye, like the Stephen Hawking wheelchair. So we are going to discuss about this, how we can make a simple Stephen Hawking type wheelchair or a robot that can be controlled with the eye gesture. So for that we have first imported the library in the code for the control of uh, GPIO pin of the robot. We have import the GPIO 0 library here, and the robot module. We have import a robot module. This robot module will help us to control the GPIO pins for the robot. And next we have imported the OpenCV library, because this OpenCV library, what it do is actually captures the video and cut it in frame by frame and pass and save that frame in a file path. Here I have set a file path and name. So this file path, it save the that video frame in JPG format with the name of image.jpg. So after saving that, it will pass that path to the iCam module to detect the eye gesture. So after that, we have the code that actually detect. Let me browse it. After that, the capture process of the video and converting it into the frame, we have to set some modules by which it can actually detect the eye and face, so that OpenCV can detect our eye and face. So for that we have this module that we have to import and set for the eye detection and for the face detection. But this is not that much necessary. You can also use the eye game module directly for the detection of the eye movement. You just need to save the frame of that video in the JPG format and just pass the path to the eye game. So here in the next step, I have passed that this file here, that I have set the file path to the eye game module. In the next step, I will showing you. Here is here direction is equal to igame dot get eyeball direction file name. So what is did do the igame module will go to the file path that is set here, and it will then process the image, get the eye part, then cut that eye part into the small piece, and then process those things, and try to get the position of eyeball. And after the getting the position of eyeball, it will try to match with the previous one. After getting this thing, it will get the movement of the eye, and this is how it can get the gesture of eye. So after this, we have to set the function. Here I have used the print function so that we can get the get the result in the terminal of eye gesture. So whatever the gesture is detected by the module, it can printed on the terminal window, so that you can see whether the eye moved toward upward, central, right, or whatever it was. Uh, After that, we have created the if function. What if function will actually check out whether the what is the direction of the eye movement. Suppose that you have moved the eye towards the upward direction. If the direction is equal to up, so we have print that moving up, or whatever the thing you want to print, you have to just print here that robot is moving up or down, so that you can get it right, that our eye has detected, and eye gesture is detected, and the robot is moving. And then we have called the function robot dot forward. So what will it do, that it push the robot toward the forward direction. And then we have created another uh, else, if condition, that will check whether the movement is down. If the movement is down, then it asks the robot, or you can say the wheelchair, to go downward or the backward direction. And it's same here for the left. I have called the function robot dot left, and for the right, for the center, I suppose that you want to stop, just you have to just give the gesture of eye to the center, so that robot get stopped. So here I have the function for the robot that will be do when the eye gesture is detected. Now the question is, how we connect what is the pin I have set for the robot control. So you can see here I have set the pin numbers. You can use your pin number according to your choice. Here I am using the 17 and 20 GPIO pin of the Raspberry Pi, and 22 and 23 GPIO pin of the Raspberry Pi for the controlling of robot wheel. So for the control of the robot, I am using the L3290 motor driver, L3290 motor driver, and you can also use the other motor driver as well, or you can use MOSFET for controlling the motor as well. So it's your choice. I am using the L3290 motor driver for controlling the motor of the robot. And so the motor driver pins have to be connected with those pins, like input of motor driver one input pin is to the 17th pin of the Raspberry Pi, and another is to the 27th, and next is to the 22, and pin number next is to the 23 pin number of the Raspberry Pi. So you can also change this for the controlling of left motor and right motor pin number as per your choice. I am using this because these GPIOs pin are three in my Raspberry Pi. Others are used already soldered with the other sensors for my robot that I am already making. So after this setting, you have to just run the code, and then bring the face in front of the Raspberry Pi. And when it detects the face, it will show you no face detected. If it's not detecting the face, actually I have a little bit of lagging. And when you move the eye, it will set the upward, rightward, downward, and it will move the robot according to that. You can see the eye detection thing. Let me give some light on my face so that it can clearly detected by this. I'm going to give a light on my face. Let me do that. So now it can easily detect my eye. You can see a box on my eye, and the movement part on the cell here. You can see that. So this is how the things work, and this is how you can control the wheelchair. You can see the wheelchair, or you can say that robot using the eye gesture. So any question answer? Are we doing code on Raspberry Pi or Python or both? Actually, the Python program is Python ideally is installed in the Raspberry Pi, and then we are programming in Python. So first we have to install the Python programming language. Here you can see I have already installed. So you have to install the Python ideally in the Raspberry Pi. Then you have to do the code, and then you have to save that code and run the code. Uh, can we use MATLAB for the coding instead of OpenCV either? Yeah, you can use the MATLAB as well for the face detection and eye detection, but the coding is the different for that. I have actually disconnected the robot part so that I can show you. This is the robot body and chassis that you need. You can use any other robot chassis, and then you have to connect the camera to the Raspberry Pi like this. You have to insert the camera to the Raspberry Pi, and then you have to fix the camera on the robot. Here I am fix the camera on Raspberry Pi like this, so that, and put the Raspberry Pi at the front of the robot like this, so that it can get my face and control it. And you can do other type of setup as well on the robot, or if you're making a Stephen Hawking type of wheelchair, so you have to put the whole setup and motor on the chair, and put this camera in front of your face like this with a stand.
Ashwini, there is a question. Shalab is asking which Raspberry Pi version is this and how can they get these codes? Nahid's question is this.
I am working on Raspberry Pi 4 module. I have forget to share this with you. Actually, it is very necessary to know which Raspberry Pi version I am using. Actually, if you run the code on Raspberry Pi Zero, because of the only limited RAM of Raspberry Pi Zero, Raspberry Pi Zero have only 512 MB of RAM. So this code will not work properly, and you face a lots of problem. And if you go for the Raspberry Pi other version which have 1 GB of RAM, then it will work, but you face some problem as well, and it get heated up so quickly. So for the best performance, you can use the Raspberry Pi 4 version with the 4 GB of RAM. But here I am using the Raspberry Pi 4 with 2 GB of RAM, and it will work fine in this as well. But I recommend you to use the 4 GB of RAM, so that everything go and run smoothly, because image processing will take lots of processing power and RAM as well. So Raspberry Pi 4 with the 4 GB of RAM is recommended, but 2 GB of RAM can also be used.
One question is from Mahavir. Mahavir is having 3B plus Raspberry Pi. So he's asking if he can work with that.
Okay. That have the actually 1 GB of RAM, that will also work, but you face some problem and a lots of heating was there. So you have to use the heat sink to run the thing smoothly, and you have to also need to do the overclocking if you face some lagging issue, or some uh, slow processing issue. So it will work, but not that smoothly. Even in the Raspberry Pi 4 with the 4 GB of RAM, it will not work so smooth. You can clearly see the little bit of lag in the video and the real time tracking of the eye movement.
Which OpenCV version is used?
I am
One
using the
question is this.
OpenCV 4. You
And
can
can they
use and
get the
install any
code?
OpenCV version.
Ashwini, can they get the code?
Yeah, code. I will publish the project on Electronics for You website. You can check there. We will share you the link after the with you guys after the Indo webinar, where we share you the videos and other things. PPT. You can also check the Electronics for You website. It was published there. You can check there as well. Very easy to coding in image processing. A hand gesture is a little bit of tricky thing for detecting the gesture from the hand, because you have to first process the video and convert into such a way that it captures the only hand part, and then it can detect the hand, because you have to separate your hand from the background as well, because sometimes uh, uh, image might not get processed that well, and your hand is detected not detected, so in so real time. So for hand gesture, it is little bit lengthy and tricky process. If you put some mark on your hand or your finger, then it is easy to track that mark in the image. Like if you put some black dot on your hand or black dot on your finger, Then in OpenCV, you can simply convert the image into the black and white, and you can track the black dot on your hand and its movement. So you have to do some trick with it so that you can separate your hand from the background. So it is a tricky part, but you can do it. Any more question?
So Nahid is asking whether we can use MATLAB for coding instead of OpenCV.
MATLAB, you can do the coding in MATLAB as well for the image processing, but here for this project I am using the OpenCV and the Python for the programming. For MATLAB you have to change the code, and you have to also see the logic how you can do it using the MATLAB.
One more question is hand or eye gesture is easy to code in image processing?
Hand gesture is, as I already told, that it is hard to do. You have to do some tricky thing, but eye gesture is easy to do with the libraries like iGame, or you can iTrack, or there are other Python libraries, open source Python libraries available. You can check the libraries of Python on the PY. There you can search simply iTrack, so you can get the list of libraries that are available for the eye tracking.
Okay, one more question from Mahavir. Sometime OpenCV is crashed while working on it. What is the reason behind this?
OpenCV crashed. Sometimes there are lots of reasons behind it. It depends on the code and also on the version of Python and the OpenCV. Sometimes when you have the code where OpenCV have to send some image to the file directly, that is like one I have done in this code. So if that if you run that code and it didn't find that particular file directory, so uh, the code will got error in the middle of execution, and the thing get crashed. And another thing is also the problem of your processing power of your development board or module. Like if you are using the low RAM, and the OpenCV is requiring a lots of memory and processing power for the from the development board. So sometimes it gets overheated and crashed up, and it might also burn your Raspberry. It not burn, but it will actually shut down the Raspberry Pi. So these things you have to first decide these things, that what are the requirement of the project, and how deep you are going to use the OpenCV and processing power, and you have to select the Raspberry Pi board according to that. uh, for high end processing, Raspberry Pi 4 with the 4 GB RAM is better.